Okay, so let's extend a little bit further now some of the exact values of our sine and cosine and tan function for that matter. So we've got the 0, pi on 2, pi, 90 degrees, 270, etc. values sort of sorted out. Now we've got 3 or 4 other key values that we have to know. Okay, so they're 30 degrees. You'll see our table here, 30 degrees, 45, 60, and 90. Well, we've done our 90, so 30, 45, and 60 for sine, cosine, and tan. All right. There's a number of ways we can do it. We memorize a table, and there's a table of values there that we can memorize. Okay. There's a palm trick that's a really, just a nice little way in which we go about learning the angles by counting the fingers, to be honest. Click on the link there and I go through the video that will go over, explain the palm trick, and that's a really nice way the boys in the past have found really quite beneficial. The other way, I suppose, is to consider 2 different triangles, okay? The first of these triangles will be this equilateral triangle. And so if we take half of this equilateral triangle here, we'll end up with 1, 2, 60 degrees, 30 degrees, and that's a right angle. So a little bit of Pythagoras' theorem here will give me, x is equal to square root of 4 minus 1. So that length there is root 3. So from there, we can actually work out from the triangle, if I want to work out what sine of 60 degrees is, well, it's the opposite side over the hypotenuse, which is root 3 on 2. Cos of 60 degrees, well, there's my 60 degree angle, and that's the adjacent side over the hypotenuse, which is a half. So we can get all the different angles. Obviously, we can do tan 60. If I want to work out sine of 30 degrees, well, it's the opposite side over the hypotenuse, which is a half, cos 60, etc., etc. So you can work out sine, cosine, and tan of 60 and 30 degrees from that triangle. All right. The other triangle that gives us the other two is this isosceles triangle, where it's a 1, 1. So again, from Pythagoras' theorem, that makes that angle length root 2. So if that angle there is 45 degrees, which for an isosceles triangle it is, it's equal to opposite over hypotenuse, which is 1 on root 2. Cos 45 degrees is also adjacent over hypotenuse, which is also 1 on root 2. Tan 45 degrees opposite over adjacent, which is just 1. Okay, so we can draw those 2 triangles at the top of your page and we can work through it. Initially, perhaps we've got this table here in front of us, just to reference it. We will always have our hand with us. So in a tech-free or tech-active environment, you've got your hand there. And whilst, just to preface the video, we'll reference your thumb or your little finger is 0 and your thumb is 90 degrees. It doesn't really matter. It's just go through the video. It's just a must. Go through the video. It's a really nice, straightforward way of remembering all our exact values. So let's make use of them. So again, look, there's not much in the way of explanation. Initially, sine of 30 degrees, okay, is a half. Tan of 45 is 1, and cos of 60 degrees is also a half. So it's just, you can reference your table if you need to. So I've got our exact values there just that we could reference. Okay, so using our symmetry properties, remembering that our symmetry properties always relate to being either plus or minus the horizontal axis. So it's either plus or minus 180 degrees, which is the same as pi. Which quadrant am I in? So C, A, S, T, if you remember, just remember the Y value is the sine function, the X value is the cos function. So cos of 150. Well, let's reference as always, cos of 150 is the same as 180 minus 30, which is the same as cosine of 30. We just need to check the quadrant. Now, 150 degrees is in the second quadrant where cosine is negative. So it's a negative cos 30. And negative cos of 30 is negative root 3 on 2. Keep that quiet. Let's go to sine 690. So what is sine of 690? So 690 degrees is the same as 720 degrees minus 30. There, 720 degrees. There's 360, 720. So it's just at that starting point, which is the same as sine of 30 degrees. We've just got to think about which quadrant we're in. Well, 720 minus 30 takes us down into the fourth quadrant. Sine is negative there, so we get negative a half. Negative tan of negative 300. So what's that going to mean? So we've got a negative out the front, tan of 300 degrees. Well, that's 360 minus 60. You could argue it's 270 plus 30, but 270 is from the vertical axis, okay? And in fact, let's think about the negative sign in there. It's the tan of negative 360 plus 60. But still, negative 360 just puts me on that horizontal axis at the starting point. So it's negative tan 60, but I've got to think about, well, which quadrant am I going to be in? So negative 360 plus 60 puts me in the first quadrant where tan is positive. So I don't have to change the sign any further. And negative tan of 60 is negative root 3. Okay. Similar, negative sine of, well, what's negative 225? That's negative 180 minus another 45, isn't it? So it's minus 180 minus another 45. So again, the 180 puts me on the horizontal axis. So I've got the negative sign at the front. That's the same as 45 degrees. Now think about which quadrant I'm in. Negative 180 is at the on the horizontal axis there at the point negative 10. Minus 45 puts me up, so it takes me up into the second quadrant where this part of it is still positive. So my overall answer is going to be a negative 1 on root 2 because 45 degrees, if I check my table, is 1 on root 2. Okay, so you just got to be a bit careful with your negative signs. What about if we're in radians? We're not used to radians. So cos of 5 pi on 4, that's the same as cos of, well, if we have to, just think about our fractions. That's 4 pi on 4 plus pi on 4, which is the same as 4 on 4 is just pi. So we're on the horizontal axis, so that's the same as cos of pi on 4. Which quadrant am I in? Pi plus pi on 4 is the third quadrant. Cosine is negative there. And cos of pi on 4 is 1 on root 2. 11 pi on 6, it's the same. You may not need this line here, but that's 12 on 6 minus 1 on 6, which is, which quadrant? Well, it's the same as pi on 6, but we're at the 2 pi mark less an angle. So we're in the fourth quadrant where sine is negative, which is negative a half. Because sine pi on 6, check the table, is a half. Again, a couple more negative ones there to think about. We've got the negative out the front, tan of 11 pi on 4. So what's that? That's the same as 3 pi on, that's 12 pi on 4 minus pi on 4. Now 12 pi on 4 is at 3 pi, which is on the, again, just the halfway mark there over at negative 1, 0. I've got the negative out the front. So that's the same as negative tan of pi on 4. Which quadrant am I in? So 3 pi minus pi on 4 puts me up into the second quadrant. Tan is negative there. So we've got another negative. Tan of pi on 4 is 1. So minus minus 1 gives me a positive 1. Finally, negative cos of negative 15 pi on 6. So we have negative cosine. Now what's 15 pi on 6? That's the same as, well, we could simplify that by 3 straight away. So that's the same as negative 5 pi on 2, which is actually on my vertical axis, isn't it? So negative 5 pi on 2, if you like, is, might come over here, negative cos of, well, it's negative 4 pi onto minus pi on 2, which is negative cos of pi on 2, but whereabouts are we? So negative 4 pi on 2 is just back at the starting point. Minus pi on 2 puts me at the bottom. So if you like, we can leave the negative in there if you like, just to give us an idea that we're down at the 270 degree area where cosine is 0. So we end up with 0. Off you go.